Ever wondered why the shape of Foundry sand grains matter? The grain shape profoundly influences the casting process, impacting strength, bond, and thermal expansion. Various grain shapes include angular, subangular, rounded, and compound. Each type with its unique properties, a distinct role. Let's dive into the fascinating world of sand grain shapes and their role in foundry processes. Let's begin with the first type, the angular sand grains. These grains are sharp and irregular, formed through rock crushing, creating maximum strength. Next, subangular grains, less sharp but balanced in strength and thermal properties, formed through weathering and erosion. We then have rounded sand grains, smooth and spherical, formed through water flow or wind action. Their shape eases mechanized core production. Lastly, the compound sand grains, agglomerated particles from angular or subangular sands found in sedimentary rocks. They blend characteristics from their constituent grains. As you can see, each grain shape plays a unique role in the casting process. Now, what happens when we compare these different grain shapes? Each grain shape offers unique benefits. Angular grains offer better bond, but necessitate higher costs. Subangular grains provide interlocking and a smooth finish. Rounded grains promote flowability and permeability. Choosing the right grain shape can significantly impact the success of your casting process.
Determining the shape of foundry sand isn't as simple as it sounds. It's a process that requires a keen eye and a patient hand. We begin by sieving the sand through various mesh sizes, separating the grains based on size. Then, under the scrutiny of a microscope, we examine each grain's individual shape. Are they angular with sharp edges? Or perhaps they're subangular with slightly worn corners? Or are they rounded, smooth to the touch? By conducting this experiment, we are able to ascertain the shape of the foundry sand. So we've determined the shape, but why does it matter? The shape of foundry sand is pivotal for mold strength, permeability, and casting surface finish. Neglecting it can lead to poor casting quality and increased defects. So the next time you think of foundry sand, remember, its shape isn't just a trivial detail. It's a crucial factor in the casting process.
Have you ever wondered why the shape of foundry sand matters? Today we will learn the procedure to study the size of sand grains correctly. To begin, we need to determine the shape of the sand. This process requires a few simple items: foundry sand samples, a microscope, glass slides, cover slips, distilled water, and a few handy measuring tools like a ruler and calipers. Not to forget, a pen and paper to jot down the observations. Firstly, it's essential to obtain several representative samples of foundry sand. It's crucial to ensure these samples are clean, free from any debris or impurities. Once cleaned, spread a thin layer of each sample on a clean glass slide. The magic happens under the microscope. Place the prepared slide under the microscope, starting with a low magnification. This allows locating an area with a good distribution of sand grains. Gradually increase the magnification to observe individual sand grains more closely. It's essential to focus the microscope carefully to obtain clear images of the grains. Through this process, we can analyze the shape of the grains. It's a meticulous process that requires patience and precision. The shape of these grains plays a significant role in the properties of the foundry sand. It affects the sand's permeability, its ability to compact, and the finish of the casting. In summary, determining the shape of foundry sand involves obtaining clean samples, preparing slides, and observing them under a microscope. By carefully focusing and adjusting the magnification, we can analyze the shape of individual sand grains. The shape of these grains has a profound impact on the properties of the foundry sand, influencing its permeability, compactability, and the finish of the casting. So next time you see a beautifully crafted piece of metalwork, remember the humble grain of sand played a pivotal role in its creation. A small grain, but a giant leap for foundry work. Until next time, keep exploring the wonders of the microscopic world.